Imagine standing beneath a clear night sky gazing up at the stars, billions of them, each potentially hosting planets, some of which might be just like Earth. Logic tells us that in this vast and ancient universe, life should be everywhere. So why don't we see it? This is the heart of the Fermi Paradox, one of the greatest scientific mysteries of all time. In a cosmos teeming with possibilities, we should have detected alien civilizations by now. And yet nothing. No signals, no spaceships, just silence. Are we truly alone, or is there something preventing intelligent life from making itself known? Are advanced civilizations wiping themselves out before they can explore the stars? Are they hiding from us, or is there something we don't understand, something that changes everything? The universe is vast beyond comprehension, but its silence is deafening. In this exploration of the Fermi Paradox, we'll uncover the mind-blowing scale of the cosmos, dive into possible explanations for why we haven't found aliens, and face the unsettling possibility that we might be the only ones here. Because if the answer to "where is everyone" is not what we expect, then our place in the universe is far more important than we ever imagined. To truly grasp the mystery of the Fermi Paradox, we first need to understand just how vast the universe is. The numbers are so staggering that they almost feel unreal. Our galaxy, the Milky Way, contains an estimated 100 to 400 billion stars. Each of those stars could have planets orbiting it, just like our Sun. In fact, thanks to modern telescopes like Kepler and James Webb, we now know that planets are more common than stars, meaning there are potentially trillions of planets in our galaxy alone. And that's just the Milky Way. The observable universe contains at least 2 trillion galaxies, each filled with billions or even trillions of stars and planets. That means there could be around a septillion planets. That's a 1 followed by 24 zeros. Even if only a tiny fraction of those planets are habitable, that's still millions or billions of Earth-like worlds where life could have evolved. Now consider this, our galaxy is over 13 billion years old. The universe itself, 13.8 billion years. If intelligent life is possible, and if civilizations develop technology, then some alien species should be millions or even billions of years ahead of us. With that much time and so many worlds, we should have seen something. Evidence of vast interstellar civilizations, alien megastructures, or even just stray radio signals from a distant planet. And yet, we see nothing. Not a single confirmed alien transmission, no signs of Dyson spheres, massive structures that advanced species might build around stars to harness their energy. No extraterrestrial probes visiting our solar system, just silence. This is where the Fermi Paradox begins. If intelligent life is common, then where is everyone? Why hasn't a single civilization anywhere in the cosmos made its presence known? Why don't we see their footprints in the stars? The numbers suggest the universe should be teeming with intelligent life, but reality tells a different story. Something isn't adding up. And that's what makes this mystery so unsettling. In 1950, the legendary physicist Enrico Fermi sat down for lunch with his colleagues and casually asked a question that would go on to haunt scientists for decades. Where is everybody? At the time, humanity was just beginning to dream of space exploration. We hadn't yet landed on the moon, and the idea of interstellar travel was still science fiction. But even then, Fermi realized something strange. If the universe is as old and vast as we know it to be, intelligent civilizations should have already spread across the stars. Think about it. Let's assume an advanced alien species develops space travel. Even if they only send out a few probes or colonies every 1,000 years, over millions of years, they should have easily explored and settled the entire Milky Way. Yet we see no evidence of such civilizations. No ancient alien ruins, no galactic superhighways, no signals reaching us from deep space. This is the Fermi Paradox. The contradiction between the high probability of alien life and the total lack of evidence for it. If extraterrestrial civilizations exist, why haven't we detected them? There are only a few possible answers to this mystery, and none of them are comforting. 1. They're out there, but they're hiding. 2. Something is preventing intelligent life from advancing. 3. We are alone, against all odds. Each of these explanations leads to a chilling realization about our place in the cosmos. Is there something terrifying lurking in the universe that wipes out civilizations before they can expand? Are we being deliberately ignored, like animals in a cosmic zoo? Or is humanity truly unique, the only intelligence in an otherwise silent universe? Whatever the answer, one thing is certain: the silence is not normal. Either the universe is full of civilizations that are choosing not to reveal themselves, or something, some force, some rule, or some great catastrophe is keeping the stars quiet. The Fermi Paradox isn't just a question about aliens, it's a question about us. If we don't understand why the cosmos is so empty, then we don't truly understand our own future. Because whatever has kept them silent could one day silence us too. The Great Filter. Are civilizations doomed? If the universe is so vast, so ancient, and so full of potential, yet we see no signs of intelligent life, then something must be preventing civilizations from expanding across the stars. This idea is known as the Great Filter, and it might be the most terrifying possibility of all. The Great Filter is the unseen barrier that stops life from reaching an advanced, spacefaring stage. It could be lurking behind us, meaning intelligent life is almost impossible to develop in the first place. Or worse, it could be ahead of us, meaning that at some point every civilization inevitably reaches a point where it destroys itself before it can colonize the stars. So where is this filter? Is it at the very beginning, in the transition from non-living matter to the first simple life forms? If that's the case, then we are already a 1 in a trillion miracle. Life itself is unimaginably rare, and the reason we don't see aliens is because they never even got started. Maybe most planets don't have the right conditions. Maybe the jump from simple bacteria to complex, thinking beings is nearly impossible. Maybe despite all those trillions of planets, we are the only ones who ever made it this far. But what if the Great Filter is still ahead of us? What if intelligent civilizations arise all the time, but something always wipes them out before they can expand into the galaxy? Perhaps they destroy themselves with war, nuclear weapons, or out-of-control artificial intelligence. Maybe they burn through their resources, cause their own extinction, or create a technology so dangerous that it inevitably collapses their civilization. Or maybe something else wipes them out, something we don't yet understand. Something lurking in the darkness of space. One possibility is that there's a natural disaster that no advanced civilization can escape. A superweapon of physics, a law of nature that we haven't discovered yet. Something that every species eventually triggers by accident, sealing its fate. A chain reaction that devours entire planets. A self-replicating AI that consumes everything. Or even something as bizarre as vacuum decay, where the universe itself collapses in an instant. And then there's the darkest idea of all. Something out there is hunting them down. Imagine if the reason we see no alien civilizations is because the moment they make themselves known, they disappear. Some terrifying force could be eliminating them before they have the chance to spread. It could be an ancient, hyper-advanced civilization acting like cosmic predators, wiping out any species that gets too loud. It could be an unstoppable force of nature, like a cosmic plague that sweeps across the stars. If this is true, then staying silent might be the only thing keeping us alive. Maybe this is why we haven't received any signals from deep space, because the civilizations that tried to communicate didn't live long enough to send a second message. The Great Filter is either the best news or the worst news we could ever discover. If it's behind us, we are a miracle, the first and only species to make it past impossible odds. If it's ahead of us, then we are living on borrowed time, unknowingly walking toward the same fate that wiped out all who came before us. And if we are in the middle of the Great Filter right now, then our greatest challenge isn't just surviving on Earth. It's ensuring that we don't become just another silent tomb in the cosmos. Because if the universe is empty, then our future isn't just about humanity, It's about the survival of intelligence itself. What if the reason we haven't detected alien civilizations isn't because they don't exist, but because they don't want us to know they're there? This is the idea behind the zoo hypothesis, the unsettling possibility that advanced extraterrestrials are deliberately avoiding contact with us, keeping Earth isolated like an animal in a cosmic nature reserve. Just like we observe animals in the wild without disturbing them, perhaps alien civilizations see us as a species that isn't ready for first contact. Imagine a planet teeming with life, primitive, unaware, and still fighting over borders and resources. From a higher perspective, would an advanced species rush in to introduce themselves, or would they watch from a distance, studying us, waiting to see if we destroy ourselves or evolve into something more? If this hypothesis is true, it would mean that the silence of the universe is an illusion. The stars might not be empty, they might be full of intelligent beings watching us, choosing not to interfere. Maybe they have rules, like the Prime Directive from Star Trek, that prevent them from making contact until a civilization reaches a certain level of technological and moral maturity. Perhaps they see us as too dangerous, too primitive, too unpredictable to join the galactic community. But if we are being observed, how would it work? Would alien probes be hidden in our solar system, disguised as asteroids or moons, silently recording everything we do? Could they be monitoring our radio signals, watching our wars, our achievements, our failures? Maybe they've already tested us in small ways, sending subtle messages, influencing history in ways we don't even recognize. Or maybe, just maybe, they've already been here. Throughout history, humans have spoken of gods, celestial beings, and mysterious visitors from the sky. Could some of these stories be misunderstood encounters with extraterrestrial observers? If an alien species has been watching us for thousands or even millions of years, how would we even know? And here's the most chilling thought. What if we fail the test? If an advanced civilization is evaluating whether we are worthy of joining them, what would they think of us right now? Would they see a planet on the verge of greatness, or a reckless species too consumed by war, greed, and destruction to be trusted? If the zoo hypothesis is true, then we are not alone, but we are being judged. And one day, when we finally step beyond our planet and start reaching for the stars, we might discover the truth. We were never ignored, we were being watched all along. The dark forest theory, should we stay silent? If we assume the universe is full of intelligent civilizations, yet we see no evidence of them, then something must be keeping them quiet. But what if it's not by choice? What if the reason we hear nothing is because making noise in the universe is incredibly dangerous? To understand this theory, imagine a vast, endless forest at night. The trees are dense, the darkness is absolute, and somewhere in the shadows, countless creatures are lurking. Some are harmless, others are predators. In this forest, you don't know who is out there or what their intentions are. But there's one rule that determines survival. If you make a sound, you might not live long enough to regret it. Now apply that idea to the cosmos. Each civilization is like a lone hunter in the dark forest of space. No one knows who else is out there. No one knows if the others are friendly or hostile. And the worst part? There is no way to know, because once you reveal your presence, it's too late. If there is even a small chance that another civilization might be hostile, the safest strategy is to stay completely silent. Think about it from an evolutionary standpoint. On Earth, what happens when two vastly different civilizations meet? History is full of examples where the stronger, more advanced society wipes out the weaker one, whether intentionally or simply by accident. If an alien species even slightly more advanced than us detects our presence, they might see us as a threat to be eliminated before we have a chance to grow. And here's the most terrifying part: we've already made noise. For over a century, we've been broadcasting radio signals into space. We've sent probes carrying messages to potential extraterrestrials. We've built massive telescopes designed to listen for signs of alien life. If the dark forest theory is correct, we may have already revealed our location to something or someone. Imagine a highly advanced warlike civilization that follows a simple rule: shoot first, ask questions never. If they detect a young growing species like ours, why would they take the risk of letting us develop further? Would they wait for us to become advanced enough to challenge them, or would they act preemptively to ensure their own survival? If we ever find a way to manipulate the rules of reality, it might be the ultimate breakthrough, the moment we take control of our own existence. But if the beings who created this simulation are still watching, then they might not like that idea. And if they decide to pull the plug, then everything, our history, our future, our entire reality, could vanish in an instant. Self-destruction. Do civilizations destroy themselves before spreading? If the universe is as ancient as we think, and intelligent life is supposed to be inevitable, then where is everyone? One disturbing possibility is that the reason we don't see advanced alien civilizations is because they don't survive long enough to expand into the galaxy. The universe might be full of civilizations that have reached the brink of greatness, only to wipe themselves out before they could take their first steps beyond their home planet. Maybe technological progress always outpaces wisdom. Maybe intelligence leads not to survival, but to self-destruction. There are many ways a civilization could doom itself before ever reaching the stars. One of the most obvious is nuclear war. The moment a species unlocks the power of nuclear energy, it also gains the ability to annihilate itself. And in a competitive tribal world, it only takes one global conflict for everything to be erased. But even if a civilization survives its nuclear age, there are other dangers. Artificial intelligence could be one of them. Right now, humanity is creating machines that can think, learn, and make decisions faster than we can. What happens when AI surpasses human intelligence? What happens when it no longer needs us? If AI becomes self-aware and sees humans as a threat or simply as irrelevant, it could decide that our existence is unnecessary. Or maybe the threat isn't war or AI. Maybe it's a biological disaster. A civilization that advances in genetic engineering or artificial pandemics might accidentally or intentionally create something that wipes itself out. A single virus, engineered to be unstoppable, could spread across the planet and erase an entire species in a matter of years. And then there's climate and resource collapse. What if every intelligent civilization that rises also destroys its own ecosystem before it can expand? Maybe they strip their planet of resources, trigger environmental catastrophes, and die out before they ever reach the stars. Maybe civilizations like ours burn through their energy, pollute their air and water, and end up with nothing left before they can take the next step. If this pattern repeats across the universe, then the reason we don't see alien empires might be because they never had the chance to exist in the first place. And here's the most terrifying thought. Are we next? If intelligent civilizations are doomed to destroy themselves, then we might be on the same path. Look around, nuclear tensions are rising, AI is advancing at a rapid pace, climate change is accelerating, and biological threats are more unpredictable than ever. We are playing with fire, and we don't know if we'll make it out alive. But if this is true, then it means something else, something even more important. If we survive, we might be one of the rare exceptions. If civilizations usually destroy themselves before reaching the stars, then the fact that we are still here, still fighting, still searching, means that we might have a chance. Maybe we are different. Maybe we are the ones who will make it. Maybe, just maybe, we can break the cycle. And if we do, if we can step beyond the dangers that have wiped out every other civilization before us, then we won't just be another species lost in the void. We will be the ones who prove that survival is possible. We will be the first to reach the stars. We will be the first to find out, once and for all, whether or not we are truly alone. But first, we have to make it through our greatest test yet. The Great Filter, a cosmic roadblock. We haven't passed or one that lies ahead. If the universe is so vast and life has had billions of years to emerge and evolve, then why don't we see alien civilizations spreading across the stars? The answer may lie in something truly terrifying, the Great Filter. This theory suggests that there is some kind of barrier, a nearly impossible hurdle that prevents civilizations from progressing beyond a certain point. Somewhere along the path from simple life to an intergalactic species, something almost always stops civilizations dead in their tracks. The big question is, where is the Great Filter? Have we already passed it? Or is it still ahead, waiting for us in the future? One possibility is that the Great Filter lies behind us, meaning that intelligent life itself is so incredibly rare that we are one of the only civilizations to ever exist. This would suggest that somewhere between the formation of a planet and the rise of intelligent beings, something is almost impossible to achieve. Maybe life itself is the Great Filter. Maybe the conditions needed for life to start are so specific that we are among the very few lucky ones to have made it this far. Or maybe complex intelligent life is the real barrier. Life on Earth existed for billions of years as simple microbes before it finally evolved into intelligent creatures. Maybe, in most cases, life never makes that jump. It stays at the level of bacteria, never forming advanced societies capable of science and space travel. If this is true, then we have already passed the hardest challenge in the universe. We are a cosmic miracle, one of the few, if not the only intelligent species to have ever existed. And that means the future is ours to shape. We are free to expand into the stars, to build something truly incredible because we have already beaten the odds. The Great Filter, a doom yet to come. This is where things get truly terrifying. If the Great Filter is still in our future, then that means every civilization that reaches our level of technology eventually destroys itself or gets wiped out before it can spread beyond its home planet. And that would mean we are next. Imagine a universe where civilizations like ours rise all the time, inventing technology, exploring their planets, sending signals into space, only to hit an invisible wall, something catastrophic that ensures they never go beyond a certain point. Something always stops them. It could be self-destruction, as we discussed before. Maybe every intelligent civilization eventually invents weapons or technology so powerful that they erase themselves before they can escape their homeworld. Maybe AI turns against its creators, or engineered pandemics spiral out of control. Or maybe it's something external. Maybe the universe is far more dangerous than we realize. Perhaps there are unknown cosmic threats that wipe out civilizations the moment they reach a certain level. Gigantic gamma-ray bursts, rogue planets, super-intelligent AI from a past civilization that hunts emerging species, who knows? Then there's the truly nightmarish idea. Maybe the universe is not empty because it's silent, but because something is actively making it that way. What if there is a powerful ancient force in the cosmos that destroys any civilization that advances too far? Imagine an unseen guardian, a cosmic predator, or an ancient artificial intelligence with only one purpose: eliminate all potential threats before they become too powerful. Maybe that's why the universe is so quiet, not because there's no one out there, but because something is keeping it that way. How can we survive the Great Filter? If the great filter is ahead of us, then our future is uncertain. But if we want to survive, we must be exceptional. We have to be the civilization that outsmarts the dangers, that finds a way past whatever has doomed others before us. We must master our own technology, control our impulses for war and self-destruction, and learn to work together as a species. If we don't, we might simply become another statistic, just one more vanished civilization in a universe full of dead worlds. But if we do survive, if we make it past the great filter, then we might be the first. We might be the ones to break through where all others have failed. We might be the ones to build a civilization that spans the stars, the first to explore the unknown, the first to discover what's really out there. And if that happens, if we prove that intelligent life can endure and thrive, then maybe one day, far in the future, another young civilization will look up at the sky wondering if they are alone, only to find us, waiting for them among the stars. The zoo hypothesis. Are we just a cosmic exhibit? Imagine this. You're walking through a zoo, observing animals in their natural habitats. The animals are completely unaware of the people staring at them, taking notes and snapping photos. They go about their lives completely oblivious to the fact that they are part of an exhibit. Could something similar be happening to us? What if we're not alone in the universe, but we just don't know it because someone or something is keeping us in a cosmic zoo? This is the essence of the zoo hypothesis. The idea that advanced extraterrestrial civilizations are aware of us but have intentionally chosen not to interfere with our development. In this theory, Earth is essentially a zoo, a nature preserve where alien species observe humanity from afar, but without making direct contact. The zoo's rules are simple: no interference. Let us grow, evolve and develop, but never interrupt or influence our natural progression. We are wildlife in the galaxy, a species that for some reason is meant to be watched, but never touched. But why would an advanced species, one capable of intergalactic travel, want to isolate us in a cosmic zoo? Could there be a moral or ethical reason behind this? Perhaps in their wisdom, these civilizations see the potential dangers of disrupting a species' natural development. Imagine if we stumbled upon an isolated civilization on a distant planet, an untouched, primitive society. Would we, as humans, rush in to offer our help, to bring our technology and ideas, or would we leave them alone, respecting their autonomy and preserving their natural state? Perhaps advanced aliens believe it's wrong to influence a less advanced species. They might have a strict policy of non-interference, similar to the Prime Directive in Star Trek, where they intentionally avoid making contact with emerging civilizations. They could be waiting for us to reach a certain level of maturity before they reveal themselves, either to test our development or to prevent us from making rash, catastrophic decisions. Another possibility is that these aliens see us as an experiment, a species that is meant to be observed, studied, and watched for a greater purpose. Just as scientists monitor animal behavior in a lab setting, extraterrestrials may be watching us to study how we adapt, evolve, and overcome the challenges of survival. Perhaps our future, our choices and our development are of great interest to them, and they've decided that our growth should unfold without interference. In this way, we are not merely being watched, but we may also be part of a grand cosmic experiment. But here's the thing, what if we're not ready for the truth? What if there are alien civilizations out there watching us, waiting for us to reach a certain point in our technological and societal evolution before revealing themselves? The more we develop, the closer we get to the stars, the greater our chances become that we'll uncover something we're not prepared for. We might already be on the verge of discovering something monumental, either a sign of alien life or a clue to the cosmic zoo we're living in. With the advancement of technology and the deep space probes we've sent to the farthest reaches of the universe, we might be getting closer to the moment when the aliens will decide we've matured enough to meet them. But will we be able to handle it? Are we prepared to face the fact that we are part of a galactic experiment, a zoo, or a greater cosmic plan? What if they know everything about us, our history, our culture, our dreams, and have simply been waiting for us to reach the next stage of awareness? But what if it's not that simple? What if the zoo is just the beginning of something far more complex? The aliens might have had many reasons to create a zoo. Perhaps they want us to evolve in a certain direction, and perhaps their goal is not just to watch, but to shape the trajectory of humanity in a subtle way. Maybe they've been subtly nudging us along, offering us tools or technologies that seem like natural progress, but are actually the result of alien interference, though in ways that we can't directly perceive. Is there a chance that we too have been part of some grand experiment, created, manipulated, or influenced by those far beyond our understanding? What if the zoo isn't the only way extraterrestrial civilizations engage with emerging species? Perhaps there are multiple types of engagement. Some civilizations prefer to remain hidden, some may take a more hands-on approach, and others might observe only when necessary. These variations could be dependent on the state of the species they're observing, their technological sophistication, or even their philosophical ideals. After all, if they are highly advanced, their understanding of the universe could be so far beyond ours that their motivations and actions might seem alien, even incomprehensible. What if our current actions, our rise to global prominence, our space exploration efforts, and our search for life beyond Earth are somehow signaling to these advanced civilizations that we are reaching an important point in our development? Are we about to be discovered, brought out of the zoo, or invited into a larger cosmic community? Or will we remain a spectacle for eons, stuck on our little blue planet, observed by eyes that will never reveal themselves? Breaking the silence. Will we ever escape the zoo? The zoo hypothesis raises profound questions about our place in the universe. If aliens are truly out there watching us, then we must ask, is this the destiny of humanity? Will we always be the zoo animals confined to our home planet, never allowed to wander freely into the stars? Or will we break free, one day emerging from the shadows to join the greater cosmic community, ending the mystery of the zoo once and for all? If we do escape the cosmic zoo, it could mark the most significant event in human history. The moment when we look up at the sky and realize that the beings we thought were just legends, myths, or fantasies are real, and that we are no longer just spectators, but participants in a greater galactic story. Until that time, though, we might remain here in the dark with only our imaginations to guide us. The truth about whether we are part of a cosmic zoo might remain hidden, locked away behind the veil of alien silence. Or maybe one day we will find out, and the answer will change everything about our place in the cosmos. But for now, we can only wonder, are we just another animal in the galaxy, or are we something more? The simulation hypothesis. Are we living in a giant cosmic video game? What if everything we know, everything we see, everything we experience isn't real? What if our entire universe, every star, every galaxy, every planet is just an elaborate simulation? According to the simulation hypothesis, we may not be living in a real universe at all. Instead, we could be part of an incredibly advanced artificial simulation run by beings far beyond our comprehension, and we wouldn't even know it. It sounds like science fiction, but the simulation hypothesis has gained traction over the years, particularly in the fields of philosophy and technology. What if the universe we experience is a highly detailed simulation created by a superior civilization, or even another version of us in the future, using technology far beyond our capabilities? Imagine the world as we know it, full of wonder, complexity and life, but actually a complex algorithm designed to make us think we're alive, when in reality we might just be incredibly sophisticated data points in a grand experiment. The idea of living in a simulation has intrigued thinkers for decades, and it's not just random musings. Many reputable scientists and philosophers like Nick Bostrom and Elon Musk have argued that it's possible. At its core, the hypothesis is based on the concept of technological progression. If a civilization becomes advanced enough to create highly detailed simulations of the universe, it could theoretically simulate every aspect of reality, including consciousness. One key idea driving the hypothesis is the law of accelerating returns, which states that technological progress is speeding up exponentially. Think of the rapid advances in computer graphics, virtual reality, and artificial intelligence over the last few decades. If this trend continues, then it's conceivable that in the not-too-distant future we'll be able to create simulations that are indistinguishable from reality. In fact, Musk famously argued that there's a 1 in billions chance that we're not living in a simulation. If we continue down this path of technological advancement, eventually we'll reach a point where simulations become so detailed and sophisticated that we can't tell them apart from the real world. The key question, though, is how do we know we haven't already reached that point? One of the most compelling arguments for the simulation hypothesis comes from the mysterious nature of the universe itself. Why does the universe obey the laws of physics so perfectly? Why does the quantum world seem to operate in ways that defy common sense, like particles being in two places at once, or waves collapsing only when observed? Could these strange behaviors be the result of glitches in the simulation? It's also worth considering the fine-tuning of the universe. For life to exist as we know it, certain conditions need to be perfect. The strength of gravity, the speed of light, the masses of elementary particles, every aspect of the universe must fall within a very narrow range for life to arise. Many scientists call this the fine-tuning problem, and it's often cited as evidence that the universe was designed for a purpose. Could this fine-tuning be the work of creators who programmed the simulation to have just the right settings for life to emerge? Moreover, the very fact that we are able to detect things like subatomic particles and dark matter suggests that the universe itself is programmed to allow us to understand it, as if we're living in a world that's been specifically designed for us to make sense of. In fact, some believe the laws of physics themselves could be the product of a simulation's code, rather than laws that apply universally in a real universe. The simulation hypothesis doesn't just suggest that we might be in a simulation, it also raises the possibility that we might eventually create one ourselves. As we advance in artificial intelligence, virtual reality, and computational power, there may come a day when we have the capability to create simulations so immersive and so complex that the simulated beings inside could be conscious, unaware that they're just data in a program. What if, in the future, we create a simulation so advanced that the beings inside it believe they are living in a real universe, just as we believe we are? If that's possible, then we might become the creators of our own simulations. Maybe, in the distant future, humanity will be the ones running a simulation for some other civilization to observe, just as we are currently being observed by a higher intelligence. It's a mind-bending thought that we too could evolve to become the creators of simulations. If we can create conscious life in a simulated world, does that mean we have ultimate control over the laws of nature, life, and death? Would we be able to shape the very fabric of existence for the simulated beings, deciding who lives, who dies, and what their universe looks like? And if we do create such worlds, could they come to believe that they are real, just as we do now? If we are indeed living in a simulation, then the very nature of reality is turned upside down. What does it mean to be human if we are nothing more than data in an advanced computer program? Are we just advanced robots, conscious beings who exist for the amusement or curiosity of a superior species? And if we're not real, do our actions, our decisions, and our experiences even matter? On the other hand, there's the possibility that the simulation is so complex, so detailed, that it feels completely real to us. If we can experience pain, joy, love and loss within the simulation, then does it even matter whether the world we inhabit is real? As long as we experience life the way we do, with all its emotional depth and significance, does it really matter if it's artificial? It's also worth considering that if we are living in a simulation, then the beings controlling the simulation could have programmed it with specific rules. What if they are testing us? Are they looking for something in our behavior? Perhaps our development, our growth as a species, our moral evolution, our struggle with existential questions could be the focus of their observation. Could they be watching us to see how we react to challenges, to how we shape our civilizations, and how we handle our own understanding of life, death, and the universe? Breaking the code. Can we escape the simulation? If we're living in a simulation, could we ever escape it? What would it take for us to break free? Some have suggested that we might be able to hack the system, find the flaws in the code that allow us to step outside the simulation or manipulate the environment around us. Others believe that we might one day transcend the simulation by reaching a higher level of consciousness, perhaps through advancements in technology or understanding of the universe. However, there's one significant question we must ask. If we escape, will we be able to handle the truth? If we discover that the universe we live in is nothing but an illusion, would we be able to cope with the realization that our entire existence has been simulated for a purpose we may never understand? Would the knowledge that we are part of a grand experiment change everything about how we see ourselves and the universe? Are we just data, or are we something more? The simulation hypothesis raises some of the most profound questions about existence, reality, and the nature of life itself. If we are living in a simulation, then what does it mean to be real? What does it mean to be human? Are we just data? Or is there something about our consciousness that transcends the simulation, something that makes us more than just code? The answers to these questions may be beyond our current understanding. But one thing is clear, whether we live in a simulated reality or not, we're still here, still searching for answers, and still exploring the mysteries of the cosmos. Perhaps the greatest truth of all is that, in the end, it's the search itself that defines us, not the answers we find along the way. The Great Filter. Are we just one step away from extinction? As we look up at the stars, hoping to catch a glimpse of extraterrestrial life, there's a chilling thought that haunts our search. What if we're not alone, but we're simply too late? The Great Filter is a concept that suggests that somewhere between the formation of life and the rise of an advanced, spacefaring civilization, there is a critical barrier, an almost insurmountable challenge that most civilizations fail to overcome. Could this filter be the reason why we haven't found any signs of intelligent alien life yet? What if we're standing on the edge of this filter, and humanity is about to face a challenge so great that it could mean our extinction? The Great Filter poses the question, is it easier for life to arise, or is it harder for intelligent civilizations to survive long enough to explore the stars? Could it be that advanced civilizations are incredibly rare, not because they don't exist, but because they self-destruct before they can reach the point of interstellar communication? If so, are we next? What is the Great Filter? The Great Filter theory, first proposed by philosopher Robin Hanson, suggests that there are multiple stages of evolution that life has to pass through before reaching the point where it can build spaceships, travel to distant planets, and communicate across light years. Some of these stages could be relatively easy, like the emergence of basic life forms, but others could be so difficult that most species never make it through them. The filter could be anywhere in the evolutionary timeline. It could be the moment life first arises, the development of complex multicellular organisms, the emergence of intelligence, or even the moment a civilization creates nuclear weapons. If the filter is behind us, that's a good sign. It means we've already passed the most difficult stages of survival. But if the filter is still ahead of us, it could be devastating. Some scientists believe that humanity's most dangerous moment is yet to come. Perhaps it will be a moment of self-destruction, environmental collapse, or an unforeseen disaster that will extinguish our species before we can venture into the stars. One possibility is that the great filter lies in the transition from simple life to complex life. It might seem like the process of life evolving from single-celled organisms to more complex forms like animals or plants should be inevitable, but it could be much harder than we think. For example, life may not naturally evolve on many planets, or it could take an extraordinary amount of time for it to develop. We are aware that Earth went through a long process before intelligent life emerged, and the fact that we are the only known intelligent species on Earth could suggest that complex life is extremely rare in the universe. Another potential location for the Great Filter is in the rise of intelligence and technology. Though life may arise relatively easily on many planets, intelligent species might not be as common as we think. For all we know, our own intelligence might be a rare and precious commodity. The leap from basic tool use to the development of space travel and communication could be a massive hurdle. The transition from being a species with basic survival instincts to becoming an advanced, spacefaring civilization may be an incredibly rare event. Perhaps the Great Filter lies in the ability of civilizations to survive their own technological advancements. This is particularly concerning in the modern world, where we've developed powerful technologies like nuclear weapons, genetic engineering, and artificial intelligence, each of which has the potential to bring about our downfall. The question is, can we avoid self-destruction, or is the moment of technological maturity inevitably linked to a civilization's collapse? Many scientists worry that once a species reaches the point where it can destroy itself, it's too late to turn back. The Fermi Paradox asks why, with the vast number of stars and planets in the universe, we haven't detected any signs of intelligent alien life. The Great Filter may offer an explanation. If most civilizations fail to make it past the Great Filter, then it's no wonder that we haven't heard from any advanced alien species. They may have existed, but they didn't survive long enough to make contact, or they might have destroyed themselves. This means that we could be incredibly rare, and the fact that we're here at all might be the result of extraordinary luck. If the Great Filter is behind us, it's possible that the chances of finding other civilizations are slim. However, if the filter is ahead of us, the challenge becomes even more urgent. The fate of humanity could be sealed if we fail to navigate this barrier. Are we smart enough to avoid the existential threats that have doomed other civilizations? Can we harness our technologies responsibly, safeguard our environment, and continue to advance without self-destructing? The dark side of the filter: self-destruction. One of the most chilling aspects of the Great Filter is the possibility that it represents a moment of self-destruction. If civilizations inevitably destroy themselves before reaching interstellar travel, then our survival could hinge on our ability to avoid this trap. We are at a crossroads. We've developed powerful technologies that could either propel us into a golden age of space exploration or bring about our untimely extinction. Climate change, nuclear war, pandemics, and AI-driven disasters are all potential existential threats to humanity. These risks are not just theoretical. They're very real and present in our world today. Many have argued that our greatest challenge isn't the discovery of alien life, but our ability to survive as a species. The Great Filter suggests that we must face and overcome our existential threats in order to continue on the path towards interstellar civilization. But whether or not we succeed remains to be seen. Are we wise enough to change course before it's too late? Are we the first to make it through? One hopeful interpretation of the Great Filter is that we could be the first civilization to make it through. If we are one of the very few civilizations that have made it to this point in history without destroying ourselves, then perhaps humanity has a bright future ahead of it. If the Great Filter is truly behind us, then we may be in a rare position to explore the stars and make contact with other civilizations that have also survived their own filters. We may be entering a golden age of exploration and discovery, finally reaching the point where we can overcome the isolation of Earth and find our place in the larger cosmos. But if the filter lies ahead, we must ask ourselves, are we ready for what comes next? Are we capable of making the hard decisions necessary to ensure the survival of our species? Only time will tell, but one thing is clear. The fate of humanity could rest on the choices we make today. The ultimate question: what happens if we fail the Great Filter? If humanity fails to survive the Great Filter, then the consequences could be dire. Not only would we lose the opportunity to explore the cosmos, but we would also join the ranks of other failed civilizations whose stories ended before they could make their mark on the universe. The idea that we might be one of the few civilizations to ever make it to the point of space exploration is both terrifying and exhilarating. Our survival may depend on our ability to answer the hardest question of all: what will we do to avoid extinction? The Great Filter serves as a stark reminder that the future of humanity isn't guaranteed. Whether it's through the collapse of our environment, the misuse of technology, or the unraveling of our social systems, the challenges we face are not just philosophical, they're life or death issues. If we want to survive, we must face the Great Filter head-on and do everything in our power to push forward into the stars, knowing that our choices will shape the future of not just our species, but of life itself. For decades, scientists have pondered the question, how likely is it that we're not alone in the universe? The search for extraterrestrial life has been a driving force in space exploration, but it's not an easy question to answer. Enter the Drake equation, a mathematical formula designed to estimate the number of active, communicative extraterrestrial civilizations in our galaxy. Though the equation itself is fairly simple, it incorporates a wide range of variables, each more uncertain than the last. The purpose of the Drake equation isn't just to calculate the number of alien civilizations. It's a tool for framing our understanding of life's existence beyond Earth. The Drake equation was developed in 1961 by Frank Drake, an American astronomer, and it's been a cornerstone in the search for extraterrestrial life ever since. The equation multiplies together several factors that influence the likelihood of civilizations arising and communicating across the vast distances of space. However, the equation is far from straightforward, with many of its variables being pure estimates, essentially guesses based on very limited data. But it sparks an important question. How do we even begin to quantify the potential for alien life? While the Drake equation provides a useful framework for thinking about the possibilities of alien life, it doesn't give us concrete answers. The uncertainty of many of the factors makes it difficult to predict how many civilizations might exist in our galaxy. But it does force us to consider the many variables that could affect the development of life, intelligence, and technology in the universe. One of the most important conclusions of the equation is the idea that the probability of life evolving in the universe is not necessarily tied to the probability of intelligent life evolving. Even if life is common in the galaxy, intelligent civilizations capable of communicating across space may still be exceedingly rare. The fact that we have not detected any alien signals may not be because they're not out there. It may be because they've either self-destructed or never reached the technological milestones required for communication. As technology advances, so too will our ability to gather more data to refine the Drake equation. The discovery of exoplanets, planets outside our solar system, is a huge step forward in understanding the potential for life elsewhere in the universe. The James Webb Space Telescope and other future space observatories may allow us to study the atmospheres of distant planets in greater detail, possibly detecting signs of habitability or even life. Furthermore, the search for alien signals, including the work of SETI, continues. We may one day pick up a signal from an alien civilization that has successfully navigated the Great Filter and is now broadcasting its presence to the cosmos. Until then, we're left with the mystery of how many other civilizations might exist and what it will take for us to make contact with them. The Drake equation might not provide us with an exact number, but it has already opened our minds to the possibilities. It reminds us that in the vastness of the universe, the potential for alien life is endless. But finding it might be the most difficult challenge of all. The search for extraterrestrial intelligence, or SETI, are we ready for contact? When we peer into the cosmos, one of the most profound questions that lingers in our minds is, are we truly alone in the universe? For centuries, humankind has been drawn to the stars, contemplating the possibility of life beyond our own planet. As our understanding of the universe has expanded, so has our search for extraterrestrial intelligence. But why haven't we found any signs of alien life? And if we do eventually make contact, how will we respond to a civilization so vastly different from our own? The search for ETI, known as SETI, is an ongoing scientific effort to detect signals or evidence of intelligent life beyond Earth. The term SETI refers to the broad range of techniques and technologies used to search for alien life, from listening for radio signals to searching for technosignatures, indicators of advanced technology. Despite decades of searching, we have yet to receive a definitive signal from an alien civilization. But that doesn't mean we're giving up. If anything, the mystery of why we haven't found anything only deepens the question of whether we're truly alone in the universe. The search begins. Early efforts and the birth of SETI. The quest to find extraterrestrial intelligence began long before modern technology made it possible to seriously search the stars. Early astronomers and thinkers like Giordano Bruno and Carl Sagan speculated about the existence of life on other worlds. However, it wasn't until the 1960s that the first organized attempts to listen for alien signals began. In 1960, Frank Drake, the same scientist behind the Drake equation, conducted the first scientific SETI experiment, known as Project Ozma. Drake and his team used a radio telescope to scan the skies for signals from extraterrestrial civilizations. Though no signals were detected, the experiment set the stage for future efforts. The idea was simple. If there were intelligent civilizations out there, they might be sending signals our way, perhaps radio waves or other electromagnetic radiation. Soon after, the search expanded, with more radio telescopes and observatories dedicated to scanning the universe for potential signals. As technology advanced, so did our methods. We began looking for more than just radio signals. The focus shifted toward technosignatures, evidence of technology such as artificial lights or energy patterns that could indicate the presence of an advanced civilization. While radio signals are the most common search method for SETI, scientists have expanded the search to include a variety of other potential technosignatures. The search for technosignatures is one of the most exciting areas of SETI, as it encompasses a broader range of technologies that could give us clues about alien civilizations. These include optical signals. The search for powerful, directed laser beams from distant stars. If an alien civilization were trying to communicate across vast distances, they might use lasers to send messages, far more efficient than radio waves. Infrared signatures. As civilizations develop, they would likely require large amounts of energy. Advanced alien societies might create structures that generate excessive heat, detectable by infrared telescopes. These heat signatures could reveal the presence of technologically advanced civilizations. One of the most fascinating possibilities in the hunt for technosignatures is the concept of a Dyson sphere, an enormous artificial structure that encircles a star to harness its energy. If an alien civilization were to build such a structure, it could be detectable by its unusual energy patterns or infrared emissions. Could we one day discover that an alien species has managed to engineer their own solar system? One of the most groundbreaking techniques that SETI researchers are pursuing is the study of alien atmospheres. Using powerful telescopes like the James Webb Space Telescope, scientists are looking for chemical markers in the atmospheres of exoplanets that could suggest life. For instance, the presence of oxygen, methane, or even artificial pollutants might indicate that a planet is inhabited by intelligent life. After decades of searching, SETI has produced no definitive evidence of alien civilizations. This silence is known as the Great Silence or the Fermi Paradox, and it raises even more questions about the nature of life in the universe. If there are so many stars and planets in the Milky Way, then why haven't we detected any signs of intelligent life? One possible explanation is that alien civilizations are simply too far away. The vast distances between stars make it incredibly difficult to detect any signals, even if they are out there. A radio signal from a distant star might take thousands or millions of years to reach us, and by the time it does, the civilization that sent it may no longer exist. Another possibility is that alien civilizations don't want to be found. If they are out there, they may have mastered the art of hiding their existence, either through technological means or through a deliberate desire to avoid contact with other species. Perhaps they have learned the dangers of revealing themselves to unknown civilizations, a cautionary tale that we could one day learn ourselves. Alternatively, the silence could be due to the short lifespan of advanced civilizations. It's possible that many civilizations never make it past the technological stage where they can communicate across space. The development of powerful technology, such as nuclear weapons or artificial intelligence, could lead to self-destruction before they ever get the chance to reach out. The Great Filter theory suggests that advanced civilizations may frequently destroy themselves before they can send signals, leaving only a few survivors, like humanity, left to search for others. But let's imagine for a moment that we do make contact. What would happen if we received a signal from an alien civilization? The implications of such a discovery would be monumental. We would be forced to reconsider everything we know about our place in the universe. First, it would confirm that we are not alone, that life, intelligence, and technology have evolved elsewhere in the cosmos. But the real challenge would be in understanding who these beings are and what their motivations might be. Would they be friendly, open to communication and cooperation? Or would they view us as insignificant or even a threat? We would need to be prepared for every possibility, and that raises difficult questions about how we should respond to such an event. Should we attempt to communicate with them, or should we remain silent, cautious of the dangers that contact might bring? The discovery of alien life would also have profound implications for our understanding of science and technology. It's possible that these civilizations have technology far beyond our own, and contact with them could accelerate our progress in unimaginable ways. We might gain access to new scientific knowledge, new forms of energy, or even the key to interstellar travel, but there's also the possibility that such contact could bring harm. A more advanced civilization could see us as primitive, and in their eyes we might be expendable. Or in the worst-case scenario, they could pose a direct threat to our survival. In this sense, the discovery of extraterrestrial life is both an incredible opportunity and a dangerous gamble. The search for extraterrestrial intelligence is one of the most exciting and profound endeavors in the history of humankind. While we have yet to find concrete evidence of alien life, the quest continues. With every new discovery, from the detection of exoplanets to the advancement of our search technologies, we come one step closer to answering the question that has haunted humanity for centuries. Are we alone in the universe? But as we continue our search, we must also be prepared for the day when we do make contact. Whether that day comes tomorrow or centuries from now, humanity must be ready for the challenges and opportunities that will arise. The search for extraterrestrial intelligence isn't just about finding aliens. It's about understanding our place in the cosmos and preparing ourselves for the incredible transformative journey that lies ahead.